Hello to everybody at the DCC banquet. I wish I could be there in person. I'm sure the food is a lot better than what I ate at the local fast food restaurant, but glad for that. But Mother Nature didn't allow me to attend this year, but we're happy that I'm able to be there as a virtual presence. I hear 8 in Morse code. You still there? I can't get any feedback from audio. Oh, okay. So you got the slides up and everything. So, anyways, I wanted to welcome you all to the banquet and wish I could be there in person. So, I'm going to talk about one of my deep loves of amateur radio called high altitude balloon flights. And I'm going to show you how not only can you send an amateur radio balloon into the stratosphere and back again, but how to send one completely around the world as a low Earth orbiting satellite. So we should be on slide 1. So go ahead and go to slide 2. Your typical amateur radio balloon consists of of course, the balloon itself. These are standard weather balloons that range in size from about 8-foot diameter to a little bit bigger than that to take a big tank of helium, about a 300 cubic foot tank of helium to inflate. We usually have a parachute. APRS is the primary digital mode we use. And sometimes we put amateur television or crossband repeater or even a simplex repeater. And I usually fly 2 or 3 APRS transmitters and a find me spot or an iridium modem as backups if I really want to get these back. Next slide, which is slide 3. We work with UAH, University of Alabama, Huntsville, and they have a student group called the Space Hardware Club. And they come up with some very intriguing payloads. Imagine that's actually a payload on the right. Could you imagine finding that in your backyard or hanging from a tree in your yard? And the eyes actually light up, so it was flashing as it flew. But inside is actually a serious student experiment. So they have great fun being creative with their payloads. And they fly 2 or 3, sometimes 4 balloons a semester. We used to have a senior design engineering class that flew 5 balloons a semester with all kinds of student experiments. Everything from stabilizing payloads to doing sensors and all kinds of different experiments that they come up with for the engineering class. It was a great hands-on experience, and they learned a lot. In fact, many of these engineering students had never really built or soldered things. They knew a lot of theory, but this was a great learning opportunity for them. Next slide, slide 4. This is about as simple as it gets for a simplex repeater payload. Just a little HT, and that's a Argent Data simplex repeater unit. And we sent this up to 100,000 feet, and we could communicate 400 miles in all directions. Your line of sight range is about that from 100,000 feet. Imagine having a 100,000 foot tall antenna tower on VHF and UHF. We had people talking from Alabama to Ohio and Michigan using this as a relay. It's a little tricky because you had to talk for 20 seconds, wait for it to record, and wait for it to come back. but people got used to it, and it's just was a great, simple experiment to communicate over a great distance. And this would be very handy in a case of communications, emergency communications as well. Next slide, which is slide 5. Of course, it always pays to have a chase and recovery vehicle if you want to get these back. This guy had a little trouble going under overpasses. He had to be very, very careful not to tilt his antennas up, but that's a complete Yaesu as-L rotor with a couple of aero antennas on 2 meters and 440. So, and it worked very well. Back in the good old days of ballooning, there was no GPS, so we had to rely solely on direction finding techniques. So what's the view like in the stratosphere? Next slide, slide 6. We have a gathering every year, typically in a plain state. This one was in Missouri, and we set up 10 weather balloons right next to each other, and 2 of them stayed within 200 feet the entire flight. This is a photograph of my balloon and Paul Verhodges and KD0QCA, where we had 3 payloads on there. And Jeff Ducklow, N0NQN, had a camera taking pictures every 10 seconds and caught this amazing photograph of a balloon entering the stratosphere at 53,000 feet. If the government had tried to do this as an intentional project, it probably would have cost $1 million, and they ultimately would have failed, I would think. So it was just a fluke, but it just took this amazingly beautiful picture. And you can see, even at 53,000 feet, the blackness of space is starting to appear. And that thin blue haze is the Earth's atmosphere. Slide 7. Once you get up above 53,000 feet or so, then that thin blue haze gets a little thinner, and this is the view from 85,000 feet solidly into the stratosphere. And the horizon, once again, is about 300 to 400 miles distance. This was done by a student, actually a middle school flight that we helped out with that was launched here from Huntsville, Alabama. Slide, before we change the slide, I wanted to show you some of the very serious experiments that some of these students come up with. And here's an example of an extremely serious experiment on the next slide, slide 8. The Angry Birds in Space was the big rage, so they decided to send an angry bird into the stratosphere, into near space. And that's a very angry bird, by the way. We did get him back. He landed in a tree. Of course, they almost always land in trees. And fortunately, a logger was out there chopping down a bunch of trees, and it landed in one of the trees he had scheduled to chop down the next day. We caught him as he was just driving out, told him the situation. He says, "Well, what's one more tree?" So he sawed down the tree that was in, and we walked right up to the front, top of the tree, 120 feet up in the tree, and pulled it out of the limbs. So next slide is slide 9. This rarely happens, landing perfectly into an open field. But I'll show you what typically does happen. Next slide, slide 10. These are the usual landing sites for balloon payloads. So typically way up in a tree, or horses and cows about to eat the payloads, or on top of an apartment building. So we've had some real doozies. One landed in a lake, and the student found somebody on the edge of the lake had a kayak, and he paddled out and got it from the middle of the lake. And as he was just about to get out to the payload, the homeowner said, "Should we tell him that there's an alligator that lives in that lake?" So we told him to grab it and head back quickly. Next slide. Now, this is my opinion, is an inspiration for modern electronics. This is a vintage stereo system. It's eco-friendly, you get exercise changing the tunes, but very difficult to keep in phase. So This is one example of the inspiration for going into modern digital communications. And on slide 12, this is another inspiration for wireless digital modes. And this is what a Cat 5 storm really looks like. Next slide, slide 13. So those are standard up and down balloons. The weather balloons, they go up and they pop at 100,000 feet. The parachute comes out and they come back down. They're typically about 2 to 3 hours in duration, and they can go up to 200 miles downrange if it's during the winter, or stay right on top of you during the summer. But lately, I've been, in the last couple of years, I've been investigating long duration Pico balloons and developing a tracker, a digital mode tracker that weighs under a half an ounce. There are a lot of challenges to making a tracker, full-blown GPS tracker that weighs that little. But if you can make it that small and lightweight, you can fly it on one of these large 3-foot Mylar party balloons, and they can stay up in the jet stream and go for a very long time, up to 2 or 3 weeks or more. So next slide, which is slide 14. Another advantage is that you only need a small tank of helium. A little 40 cubic foot tank of helium or hydrogen can be obtained minimal cost, and you can do 20 flights or more out of one of these tanks. Whereas one of those big latex balloons, the balloon cost over $100, and the tank of helium, with the rising cost of helium nowadays, it can be astronomical, stratospheric, if you will. So this is a very economical mode of flying, and it gives you a multi-day, multi-week flight, which the students just love. Once you get them evolved for STEM experiments, when you get a smartphone in the picture, when they can use their smartphone to track a balloon, and you've got them hooked, particularly if they can follow it over the course of several days as it's traveling across the Atlantic to Europe or even around the world. Next slide, which actually that's slide 15, I believe. There are a handful of us designing ultralight payloads. Most of them are on APRS, although there's some on Whisper and other digital modes, and we'll be talking about that here shortly. So we've got M0XER, Leo Bodnar is one of the pioneers in this Pico ballooning field. He's out of the United Kingdom. Andy VK3YT out of Australia. QRP Labs, Hans Sommer, and actually he's in Turkey. And Thomas Broll, SB9UOB, and W7QO in Atlanta, KT5TK out of the balloon launch team in Texas, and KD2EAT. These are just a handful. There are a number more that are popping up at the moment. So next slide, which should be slide 16. There's a big challenge with flying an APRS balloon around the world. And that challenge is there are multiple frequencies used for the APRS network. In the red there, that's the United States, 144.39 is the APRS network frequency. In the green, 144.800. And there really aren't that many APRS sites in Africa, mostly South Africa and Europe and Russia. But I actually have had reception on a round the world balloon in Siberia by a Siberian ham on 144.800. Now, the other challenge is China is 144.64, and Japan is 144.66. South Korea is 144.62. Why couldn't they just move 20 kc and go to one frequency? I don't know, but it made a lot of trouble for me. And then if you go into the southern hemisphere, there's 5 different other frequencies you have to worry about. So I've solved that through a geofencing algorithm. And the next slide, which is slide 17. I put and there's also areas of the world that you cannot transmit over. Uh, Believe it or not, Great Britain is one of those. The United Kingdom. They have a holdover rule from World War II where you cannot use amateur radio in airborne vehicles, be it an RC plane, a drone, a hot air balloon, a regular plane, or high altitude weather balloon. So we have to stop transmitting when we were within that yellow box. So I draw a box of coordinates around Great Britain, and when that when my GPS says I'm inside that polygon, it'll stop transmitting until it's on the other side of it. And this is an example of one of my flights, student flight KD0VJI, and it stopped transmitting right as it hit the border. That proved that the geofencing algorithm actually worked. Now, you can find this algorithm. It's called point in poly, in other words, point in polygon. And it's a floating point algorithm. And it's online for anybody to download. But the trick is to make it a non-floating point algorithm so it works great on a little microcontroller. And I have to thank KD2EAT, Mike, and Alan W7QO for coming up with an integer-based point and poly routine. And it's not quite as accurate, but we really need to have it within a few hundred feet of the border. So it's accurate probably within a mile or two, so that's good enough. And it runs very quickly and efficiently on just a little Atmel processor. Okay, next slide, which is slide 18. So I came up with a tracker. I call it the Skytracker. And it's a complete tracker with onboard GPS that can transmit on VHF or HF, APRS, or whisper modes. And the little white block on the left is the U-Blocks Max 7 and Max 8. Then I have an Atmel 328 processor, same as used in the Arduinos. A digital analog converter to create the tones for the APRS. And that's a little Cypress clock synthesizer. That silver IC at the bottom right is a reference clock for that, but it's a voltage control crystal oscillator. So I take the audio tones and I run it into the voltage control pin and I get direct FM modulation. And then the low pass filters on the right. So with this arrangement, I get a whopping 25 milliwatts on 2 meters and also HF. But believe it or not, since APRS is a very quick burst, it competes well with a 1 watt or even a 10 watt transmitter on balloon flights because it can be heard 100, 200 miles range when it's in altitude at 30,000 feet. It actually compares very well once it goes above about 1,000 to 2,000 feet. I have very few dropouts during a flight. So just that small amount of power. And on whisper mode, that's the beauty of whisper, is that 25 milliwatts can actually be heard on the other side of the world given the right conditions. So next slide. Now I put a 0.47 farad, you heard me right, farad, supercap on the back. It only weighs 0.8 grams. About 20 years ago, that would probably fill my dining room table and weigh several pounds, maybe 20 or 30 pounds. So this helps when I have lower sun angles on the solar panels because I can't tilt them, and it stores energy when I do transmissions. And I put the GPS and power saving modes between readings as well to make sure I can get a low enough sun angle during the flight. Now the only drawback to these supercaps is their maximum voltage rating is 5.5 volts. So once I stuck a 9-volt battery on this to test everything, walked away, just remembered all of a sudden, oh, 5.5 volts max. Before I could get back to the experiment, I heard this gigantic kapow. Next slide. And that's what happens when you let the smoke out of a half farad supercapacitor. So it sounded like a firecracker. And no, it doesn't work anymore. Next slide, which is slide 21. The real challenge to making a tracker that weighs 12 grams, less than half an ounce, complete with solar panels, is that you can't afford to have a battery on it. So it has to be totally solar powered. So daylight operations only. I have flown a 4-gram battery, but they don't function well. Those LiPo batteries don't work down at nighttime temperatures. It'll get me a few hours in the evening, but I lose a lot of float altitude by putting a battery on it. So lately I just fly during the daytime, and I don't get any telemetry at night. So I found a board house in China. It was hackvana.com, but it's actually JLC PCB or PCB Wow. Those are two houses I work with. They made the board 1/3 the normal thickness, which saved me a gram or two in weight. It made a big difference. And so and they're very high quality boards. So when I send the Gerber files to them, and I get the boards back within a week, and they're great, and they're inexpensive, and they're solder mask, and they just are, and they also have the silk screening. Next slide. This is the complete Skytracker with the solar panels assembled. I use a brass tubing to hold the solar panels onto the Skytracker board, but it also, the brass tubing, serves as the ground return for the solar cells, so I don't have to run separate wires. I found this extremely lightweight brass tubing from Albion Metals out of a place called Sprue Brothers, and it's only 0.8 grams. The tubing I found in the local hobby store was 3 grams, so I was fortunate enough to find these really incredible brass tubing, but it's still sturdy enough that under normal conditions, although I have smashed these into the ground at takeoff, that they work pretty well. The other thing I use are power film solar flexible solar panels. They're not as efficient as monocrystalline cells, but kids like to handle them when you take them to a school and do a STEM activity, and they like to touch it. If you tried that with a monocrystalline cell, it'd break off like sand. Once again, they also sometimes in a high wind, they'll crash into the ground, and they won't affect them. They're very sturdy. Whereas with a regular solar panel, they would just crack right in half. And I don't have the weight budget to put some backing on the back of a monocrystalline cell. So I found these have been efficient enough, and they're inexpensive enough that they work rather well. And they're extremely lightweight. Next slide, slide 23. So the small size, a little 1 cubic foot of helium or hydrogen, and this regular old party balloon. Now it is a special balloon. It's made by Qualitex. You can buy these at party stores, but I found that certain batches of Qualitex work better than others. So I buy a whole bunch of them when I find a batch that works better. So they had one batch in 2017 that they lightened it by 5 grams. So I think they took a layer of material out of it to save cost. But fortunately, they went back to the old 38-gram weight balloons, because now they work again. The 2017s didn't work too well. I flew one of those for the AMSAT conference, and it popped over Chattanooga. And by the way, for any of you who were there at that conference, I got a phone call 3 months later from an airport manager in a small airport near Chattanooga. He had found the payload that we launched at the AMSAT conference underneath of a Cessna. Apparently it had been hanging in a tree near the airport for several months, and a storm blew it out, and it decided to try and tie down at the underneath this plane, and it was in perfect shape. I just cleaned the dust off, and I flew it again. So, but we did get that one back. All right, next slide, slide 24. It's so easy to launch. Only one person needs to hang on to it, and off it goes. So that's what it looks like with the party balloon and the Skytracker with the solar panels ready to fly. Next slide. How far can they go? We're on slide 25. Well, after 6 days floating at 27,000 feet, my little party balloon ended up off the coast of Sweden, having crossed the Atlantic Ocean in 32 hours, almost the exact same route and the same time as Lindbergh. It actually showed up near Paris after 32 hours. And it spent several days crossing Europe before it hit an ice storm off the coast of Stockholm. And so we covered quite a bit of ground in the week's time. And that was one of my very first test flights a couple of years ago. Next slide. There isn't a number on this one, but it's West Point Middle School. We do a lot of school STEM flights with these because they're so easy to bring into a school. The kids get excited, and I usually ask them a trivia question about space and science, like who was the second man to step foot on the moon? And whoever gets it right, I let them launch the balloon. So we had the entire 6th grade class of this middle school out there for the flight. And once again, it's very easy to launch, and it gets the kids really excited about STEM activities and amateur radio. Next slide. And there you can see all the kids staring up at the balloon and how excited they are. And once again, they're tracking it on their smartphones. So they're really excited, and they just were glued to the screen watching it as it hit the jet stream and started heading east towards the Atlantic Ocean. Now, how far did they go? Next slide. We went all the way from Cullman, Alabama to Morocco. So in about a week's time. All right, next slide. We should be on the Dayton Hamvention 2018 Pico balloon flight. And for the last 10 years, or more actually, we've been launching weather balloons from the Dayton Hamvention. And the last 3 years, we've been launching these Pico balloons and having a race. We get 3 or 4 of them together, and we pick some students and some other hams together, and we make a race out of it. So this year, for those of you who are at the Dayton Hamvention, it's now at the Xenia County, Greene County Fairgrounds in Xenia, Ohio. And it's really a nice setup, and the food variety is really good. So we launched it from the food court. We only launched one. We were going to fly 3, but we had thunderstorms all around and very high winds, so we decided to risk 1. So next slide. And you can see it's heading over I believe that's the Marconi building, and it actually hit the top of the roof as it went by and skidded along the roof. So we all ran around the outside of the building to see if it had made it across the roof. And then this happened. Next slide. That is the W8BI hex beam on HF, on their primary HF station at the Dayton Hamvention. And it acted just like a spider web for Pico balloons. If I'd have tried to hit this antenna intentionally, it would have been a 1,000,001 shot. And you can see the little tracker dangling to the right there, and they rotated the antenna and moved it up and down and did everything they could to shake it loose, and every time they did something, it got tangled up even worse. Finally, they started to lower the tower, and it fell off. And it headed off and tangled immediately into a power line and sat there for two minutes or more. So it made it past the power line, and then it hit a thunderstorm an hour later and dropped from 27,000 feet down to about 2,000 feet and somehow made it past the storm and went back up. So after all that, the little balloon that could, next slide, it ended up in Turkey after 11 days, crossing the Atlantic in northern Africa, and it finally came down in the Black Sea after 11 days. But it went through quite a lot, but still survived. Now, next slide. And this is the Dayton Hamvention 2019. And this is the BalloonSat Forum. We hold a forum about high altitude balloons carrying amateur radio, and we do that every year. This year it was out in the tent, so I had a full tent. There's quite a lot of activity and interest in this, although I will say that on a rainy day I get a bigger crowd. So, but look for us. We're usually Fridays around noon on the Dayton Hamvention, and for those of you who do high altitude balloon flights of any sort, contact me because I'm organizing the talks for next year coming up here in the next few months. So I'd like to have a variety of speakers from around the country. So this year we decided to do the full up Pico balloon race with 4 balloons because the weather was perfect, except it was very windy. Next slide. So you see, we're prepping to bring the balloons out to the launch site, which was right next to the flea market area. And it was a beautiful day, but the winds were about 15 knots, which is well over the limit I recommend for flying one of these. Next slide. Now, this might be a first, but this is the very first astronaut launching a ham radio balloon. This is astronaut Doug Wheelock, KF5 BOC. And he waited for the other 3 people to launch their balloons to make sure he got his just right and perfect. So now there is a link down there, a YouTube link. If you click on it and let me know if it plays, it might show up underneath the presentation, but hopefully it'll pop up and you can watch this 4 or 5 minute video of the balloon launch. And unmute your microphone if it doesn't, when the video is done playing, or if it doesn't work. Okay, so I got a text message that you can't do YouTube. All right. Okay, so we'll go on to the next slide. So the end of the race, this is the last the balloons were heard off as they entered the Atlantic Ocean off the coast of Cape Cod. And W8BI-11 was the winner, launched by AK0SK. And you can see it's about 20 miles ahead, but pretty nice grouping of the balloons. So next year we plan another race, and hopefully the winds aren't quite as high. If you get a chance, though, we can share that link on the video. If you search for Dayton Hamvention 2019 balloon launch on YouTube, you'll get to see the astronaut Doug Wheelock launch the balloon along with 3 other fellows. So next slide. I want to talk a little about the weak signal modes that we've used on these Pico balloons. Because once again, we're running about 25 milliwatts, both on VHF and HF. So one of my first tests was Hillschreiber, and it works rather well. Of course, I didn't have the timing set up just right. You can see it's kind of slants, but it's basically you take characters and it's a short on-off. Okay, they say they're going to post the presentation shortly after the conference, so you can click on that video link on the on astronaut liftoff. So, anyways, the you can see it visually shows the telemetry and the call sign, and your eyes do the filtering. So it's a very easy mode to implement. You just set up some characters, and you have on-off. It's an on-off key mode. You just get the timing right, and key down is black and key up is white, and you can form the characters that way. So the only drawback is it's hard to store flight data after the flight. So next slide. Several groups, University of Bristol in Great Britain, their SEDS group, and SB9 UOB have successfully implemented Contestia, both in UHF and VHF. And this is actually a reception I made of a Contestia balloon on UHF, launched 10 days earlier from Great Britain, had gone 3/4 of the way around the world, and got within my RF footprint here in Alabama. So I was able to copy their signal quite successfully. I used DL FL Digi, which is a balloon modified version of FL Digi, and it works rather well. The nice thing about it is there's the main modification is that whatever you decode is uploaded to a server and plotted on a map showing the balloon's position. So that's DL-FL Digi. And the W1HKJ, actually, who wrote FL Digi, lives about 20 miles north of me here in Huntsville area, in Huntsville, Alabama. So next slide, which should be slide 39. There is also a way of decoding these digital modes through a web radio, like a web SDR or global tuners, and SDR.HU. And this, I successfully copied a Contestia balloon as it was flying over Arizona through an Arizona global tuner, hooked, and I just looped the audio into my FL Digi program. So I've done this in certain areas where I fly across, for example, Siberia, where there's a number of web SDRs radios, but there's no APRS ground stations. And I've actually decoded one of my balloons over Siberia through one of these web SDRs and used Direwolf to decode it and post it to the server. So I actually received APRS from 7,000 miles away this way. So next slide, should be slide 40. Now in HF, VK3YT came up with using JT9, but he modified the actual JT9 code, the whisper, forget what that, yeah, it's JT9. So he, the K1JT code, he modified it to make it, whenever it received his data, it would send it to his server. Unfortunately, he had to distribute this modified version all over as far and wide as he could. So he just had a few ground stations out there, and although it worked well, it was also very limited data and limited ground stations that had the modified software. But I was able to copy his transmitter running about 20 milliwatts. Even from Australia, I could copy it here in Alabama on 10 meters and 30 meters. 20 meters and 30 meters. Next slide, slide 41. Of course, there's good old CW, real easy to implement into a microcontroller. You let your brain do the decoding. Teletype, also very easy to implement, but easily disrupted by noise and not very weak signal. One of my favorite modes is Domino EX. Great weak signal copy and very immune to a drifting signal. Unfortunately, none of these have a distributed network of ground stations with software that uploads data to a server like APRS does. Wait a minute, Whisper does. So, next slide. I decided to incorporate Whisper into my Skytracker, which, by the way, is not easy to do on a small little microcontroller. I used W3PM, Gene Marcus, a very good friend of mine who lives also here in Huntsville, Alabama. He had already ported the Whisper code to an Atmel processor, so I modified it for balloon use, and it works very well. So this is an example of one of my flights. The balloon running 25 milliwatts to a magnet wire antenna, 17 feet up and down. The antenna weighs 1.5 grams for each leg, 3 grams for an HF dipole. It's 36 gauge magnet wire and fishing line. And I feed it at the middle as a transmitter. So this is an example from 25 milliwatts on 20 meters over the middle of the Atlantic. I'm getting reception on both sides of the Atlantic in the US and Europe, and completely on the other side of the world in Perth, Australia. So typically it's 1,000 to 2,000 miles or so, but every once in a while you get completely on the other side of the world. So that's the big advantage of Whisper mode. But Whisper mode is very limited in what you can send. It's your call sign, a 4-digit grid square, and a 2-digit power level. And it's not every power level. It's like 3, 5, 7 dBm. So there's only like 16 or 17 power levels that you can deal with. So I modified the Whisper code as follows. And next slide. Oh, the big advantage is you have all Whisper reports are sent to this database. So what I did is I send my regular call sign, and it takes about almost 2 minutes for transmission. So instead of the power level, I send the power level, of course, as a 2-digit number, but it actually equals the altitude in 1,000-meter increments. So it's not really sending my actual power level, it's sending the altitude. So I incorporate the altitude. And then I send a second transmission that begins with a 0, 1, or Q, which are invalid call signs. And I embed the solar panel voltage, the temperature, the satellite status, and the fifth and sixth grid square digits, characters, into the call sign. I leave the grid square alone, and then the second transmission, that telemetry call sign, the power level is the altitude in 60-meter increments. So then I developed, next slide, I grabbed the data from both transmissions with a Python script. So every 10 minutes, it picks up both transmissions. If it gets both of them, it will decode the data, both the altitude, solar panel voltage. It mixes the two altitudes together, so I get the altitude accurate within 60 meters. And then I get the satellite status and the temperature, all with 2 transmissions on Whisper. Plus, the added advantage, I now have a 6-digit grid square, which gives me about a 2 by 3 mile zone instead of like 200 by 300 miles or 100 by 200 miles, somewhere around there. So this Python script just keeps running. It grabs the data from whispernet.org and plots it, reconverts it into an APRS string format and sends it directly to the APRS IS servers. And I can plot a Whisper balloon on aprs.fi and tracker.habhub.org, just like it was an APRS balloon. Next slide. And as you can see, there's a balloon over the middle of the Atlantic, and it is far, far away from any ground stations on APRS, all done by converting Whisper to APRS with my Python program. And there's an error. It shouldn't say tracking.habhub.org. It should say tracker.habhub.org. So that's website tracker.habhub.org actually shows you all the balloons, ham radio balloons that are flying in the world at any given day. So next slide. Let's see. Well, I've been using a little bit bigger balloon. It costs more. It's about $149, but it's about the size of a large leaf bag, 3 foot by 7 foot. And it has the advantage of flying at around 40 to 45,000 feet, which gets you greatly above the chances of being hit by a storm. The 3 foot balloons tend to fly around 30,000 feet and put you at more risk of being hit by a storm. So they have been known to go completely around the world, but these make it much easier to go completely around the world, and in fact, multiple times. So scientificballoonsolutions.com, it's their SBS 13. They are now producing a machine-sealed balloon, which is more reliable. And they've had 2 successful test flights of the new balloon that have been up now for almost a month. So actually 3 successful tests now. So their new heat sealing process seems to be working rather well. So next slide. One of them, I didn't notice the big hole in the box that somebody at the U.S. Postal Service had run a forklift through the end or something. So I flew it, and there was a big hole in the end of the balloon because it had punched all the way through the box. It landed about 4 miles southwest of me. I figured it out when I saw reports from 1,000 miles on either side showing it in the grid square right next to me. But it's a 2 by 3 mile area. That's a very, very small needle in a large haystack. We just got lucky, and we listened for the carrier, and when it got strong, we found it hanging perfectly upright with the solar panels straight up at the sun, 1 foot off the ground, hanging from a fence post behind a barn about 4 miles from my house. And the unusual thing is, we landed a student experiment on this very farm 3 years prior, and he remembered us. Next slide. So this is the successful launch on the way around the world that we did back in November of 2016 with whisper mode on 20 meters. Next slide. It stayed up 75 days, went around the world 6 times, and finally went down to the equator during its last round on the 6th flight around. And the equator is a rough place with very high storms, and right off the Ivory Coast of Africa, it hit a large thunderstorm and came down in the jungles right near the coastline of the Ivory Coast. If you all want to go out and get it for me, I'll give you the coordinates. But it might be a little dangerous place, lions, tigers, and the like. So, but it's there for anybody who wants to go to the Ivory Coast of Africa to retrieve it. So we've had great success, and that was with one of those SBS 13 balloons. Next slide. We had sent the first middle school to circumnavigate the world with a balloon. And I did a Skype call to help them inflate it. And their call sign was KD0VJI-11 after we did the conversion with APRS. So they actually, this was not a whisper balloon, they actually did fly APRS. You don't get tracking across the oceans, but surprisingly a lot of good coverage across Europe, parts of Russia, and China has got a great deal of APRS activity, and Japan, of course, as well. So they had enough APRS coverage that they were able to track it as it went around the world on APRS, and they went around 1.5 times with this flight. Next slide. This is the UC San Diego students. They stayed up 3 months, and they went around the world 6 times. They were last heard, I believe, off the coast of Japan. although it looked like they were going to head down towards the equator. So I want to talk about what happens when one of these balloons don't work. So next slide. W6SUN had a whisper flight from Mount Carmel High School near San Diego. And it developed a leak and landed in the desert about 150 miles away near 29 Palms, California. Now, a 6-digit grid is 3 by 5 miles in sand and small shrubs. Once again, a small needle and a large haystack. So Mark, W6MAF, he searched and searched several times out there. He came out several days. He finally went out with a Jeep and an HF receiver and an HF whip, and he listened for the strongest signal strength. And he kept driving around until he finally got, it was almost pegging his S meter. And he says, and then he spotted the balloon right in front of him. So he gets out, excited, finds the balloon, grabs the line and starts tracing it back to see if he could find the Skytracker, and found it, next slide, underneath his tire. So that's why he was getting a big, strong signal. He was right on top of it, quite literally. But believe it or not, all it did was bend the brass tubing a little bit, and the solar panels, I guess, still work. So they can be found. It's just a little bit of a challenge when you've got a 2 by 3 mile search area. So with that, next slide. We actually did this for the Weather Channel. We sent a man up on an easy chair, just like the movie Up, and there was a ham, and he went up to 14,000 feet and stayed there for 9 hours and ended up in Georgia. So there are 66 weather balloons to lift a person up to 14,000 feet. And he has big bags of water ballast that he drops off in order to go back up, and if he wants to come back down, he cuts a balloon loose. So with that, I'll stand by to see if you all have any questions.
We'll have to relay the questions to him. Okay, so questions? Oh, come on.
Okay. Yes. Oh, yes, he came down in a tree. His name is Jonathan Trapp, and he landed in the top of the trees right on the edge of the Cohutta Wilderness in Georgia. And that's where they filmed Deliverance. And I told him, you better come down now because you're heading for Deliverance country. So he did. He said, it's so nice up here. I don't want to come down. I says, there's nothing out there. My chase crew can't get you. So he cut 3 balloons down, came down, landed in a tree. He had to dump a bunch of water out and struggle. And then he came down in a cow pasture. So now he's neutrally buoyant, just bouncing along. And my chase car comes in a dirt road to pick him up. He's got 100 cows following him. So, but he was successfully recovered before the cows got to him.
Okay, Bill. What's on the whisper modes for the balloons? Are you limited to just the lower frequencies, or can you do on like 10 meters and all?
Yes, I can go to 10 meters, but the 10-meter band right now hasn't been open very much, although I am a 1010 number, but I haven't been able to give anybody my number for a long time. So primarily the best band for whisper ballooning is 20 meters during the daytime and 30 meters at night. If you rig up a battery, 30 meters at night works phenomenally well. But of course, the antenna is now 50 feet long instead of 34 feet.
So what's the?
But the best mode is on 20 meters. There's one flying right now, just south of New Zealand, launched by the AMSAT LU group in Argentina, LU1 ESY. That's LU1 Echo Sierra Yankee. And you can track it on APRS because I port it to APRS under -13. And if you go to APRS FI and enter LU1 ESY-13, you'll see where the Whisper balloon is right now, and it's on its second lap around the world. Bob ZL1RS, Zulu Lima 1 Radio Sierra, he has got a really nice beverage antenna set up that really pulls signals out to the front and greatly improves the signal and noise. And he can copy this 20 milliwatt balloon out to 5,000 kilometers or more. So he's the one picking it up today. Yeah, it's just south. I'm looking at it right now. It's just south of New Zealand. In fact, it just decoded. I have my Python script running right now. So he's in grid square RD34. And that's about, he's at, wow, 55 degrees south. He's heading down towards Antarctica. In fact, it might actually cross Antarctica here in the next few days, but in the next 2 or 3 days, it'll make its second lap, and he's running one of my Skytracker Whisper boards.
So,
yes.
I might have missed this earlier. How much does one of these balloon and boards cost?
Oh, okay, that's a good question. When flying the party balloons, the little Mylar party balloons, they're $3 or $4 a piece. But if you buy one of my trackers, I usually include one of those balloons from a known proven batch. I have like 50 balloons right now from the batch that I tested out that works really well. So I always include one of those unless you're going to fly the SPS 13s. Now those cost about $149. So, and they'll take about 4 cubic foot of helium or hydrogen, and you have to heat seal those. You don't have to worry about that with the Mylars.
Do you have
the Skytracker is $149, ready to fly. I include all the strings, tape, weight, and the balloon. You just take it out, hook it up, and let it go. For the APRS version, it's $149. It's $159 for the Whisper version because it takes me a while to build the antenna. And keep in mind, there is some assembly and soldering with the Whisper mode. One, because you'll have to cut the antenna to length and solder it to the board through hookup wire. I have strain relief hookup wires so that the magnet wire doesn't snap. So, because 36 gauge magnet wire is about the tensile strength of a human hair. So we have to tape it to fishing line and have some strain relief on it. And if you fly the Whisper balloon, I would recommend one of the larger, that SPS 13, or you can actually tape 2 Mylar balloons on top of each other and go up about 3,000 feet higher.
Okay, one more question?
You said before that with the magnet wire you use a center-fed dipole, is that correct? And
Right.
And how do you separate the legs of the dipole?
I'd solder them directly to the board, to the feed point and the ground plane. But they're separated. They are separated by 2 inches, so I actually measure the top antenna. The wire is shorter because I count the board as part of the ground plane. No, one dangles up, supports the tracker, and one dangles down. Yeah, it's not horizontal. It's a vertical dipole. So you got one wire going up to the balloon from the tracker, and then the other leg of the dipole goes down from the feed point straight down.
So I noticed that when you fill the balloons, they're not filled very full, and I know with rubber ones, you fill them so that they get bigger and bigger and eventually burst. So how do you keep from overfilling the balloon? I presume it gets fatter at the altitude that it flies. Is that right?
Yeah, with the Mylar balloons or that sushi wrap, that's actually called Heptax. It's a plastic food wrap on the bigger balloons. What they do is they do stretch a little bit. So your free lift, it's the amount of lift that you put in above the weight of the payload. It allows you to, of course, get off the ground, but it translates and it pressures the envelope when you reach the neutral buoyancy altitude. So the balloon material will stretch, but then there's a limit where it can't stretch any farther. And if it's strong enough material, then you have what's called a super pressure balloon. So it maintains a positive volume both day and night, so it will float at one altitude day and night, but you have to have that overpressure to do that. So that's where that 3 grams of free lift and for the small balloon goes into. But if you put 4 or 5 grams, it will likely burst the balloon. If you don't put enough in, like 2 grams, you may not survive the night. It might come down at night. So it's a fine 1 gram plus or minus line. I have flown 4 grams successfully, but 3 is what I recommend. Now in the larger balloon, the suture wrap balloon from Scientific Balloon Solutions, that balloon, it stretches 10 to 20%, but does not burst as long as you don't put about anything more than 8 or 10 grams of lift. Although we have had some failures in some of their batches in the last year or two, even with 5 or 6 grams of lift, which is kind of on the low end. So they recommend between 5 and 8 grams. But their new machine seal balloons, they just have 3 of them up in the air for the last month or two. They seem to all be working well. They were hand sealing them before.
Okay, I'm going to try talking into both mics at once, and hopefully we don't get feedback. Seems fine for now. All right. Question about the Pico balloons. When I see a metallized mylar balloon and there's radios involved, I think of Project Echo. Since you know where they are, have you tried using them as passive reflectors?
They're too small. I've actually had the local airport see if they could detect it with their radar. You would really need a corner reflector to be optimal. And even with a corner reflector, which are about the size of a Pico balloon, they had very poor returns on it, even no more than about 20 miles from the radar site. But they also have one other thing. They filter out anything flying less than aircraft speed as a general rule. So if it's slow moving, you wouldn't even show up on the radar. But that's a good question because I actually did see Echo when I was a kid.
Okay, quick question. I just want to know, have you had a balloon or do you know of one that has circumnavigated and has been recovered?
Almost. KD-2 EAT circumnavigated the world. It came down about 200 miles after making a complete lap, hit a storm, and it is on a mountain in New Hampshire. And he got within probably a mile or two of it, but it was so rugged and so overgrown that he couldn't get to it and it was transmitting for several days its position. So it's obviously they're solar powered. So he almost got to it, but yeah, I put a reward, an email on each of the solar panels, on one of the solar panels, and hopefully I have gotten several of them back that failed that over the United States. I haven't got one back from another country yet, but I have gotten several back that people find in Canada and the United States.
Next question.
Do you have to do any coordination with the FAA or military?
No, there's part FAA 101 rule for high altitude balloon soundings that limits your weight to 6 pounds per payload, total of 12, without having to file for a special waiver. Now, I have flown 15 pounds before for a NASA project, and it didn't take too long. It took me about a month to get the waiver process in place. Then I have to coordinate with the flight, the regional flight center, as well as the local airport here when I lift it off. But generally, for the latex balloons, we always keep things under 12 pounds total, 6 pounds a piece. And then as long as you aren't flying through, if you're flying through a congested airspace, such if you're real close, your launch site is close to a big international airport, it's always a good idea to call the airport and file a notice to airmen, which is easy to do. And then you just call the tower and ask for the optimal liftoff time so that there's less risk of any flights being in the area at liftoff if you're close to the runway, probably within a few miles. But generally, you don't have to even do that. And with these Pico balloons, obviously a half an ounce is well under the 12-pound limit.
When you were talking about the geofencing algorithm and you had to write an integer version of that, I was wondering, are you aware of a chip called the NavSpark, which is basically a GPS chip that you can run your own code in it? It seems like it'd be ideal for payloads like this, and I'm curious why no one's using it.
Yes, I've looked into the NavSpark, but I found I was so used to, and I love the performance of the Max 8, that I decided, and then I'd have to learn the NavSpark system. But I have looked into using a NavSpark, but I just stuck with the Max 8, both for size and current drain, because there's a power saving mode on the Max 8 that works really, really well.
Okay, Bill, thank you very much. I think we're going to wrap it up for the evening, and we really super appreciate you taking the time to Skype with us and give us your adventure. Thank you very much.
All right, well, I wish I could be there in person.